All right, we should all be on this page. So yesterday we talked about how to find angles inside of these polygons. And if you remember, I said that's going to come into play yet when we're talking about finding area of our regular polygons. Because after those shapes that we talked about last week, you know, each one that we've talked about, triangles, rectangles, trapezoids, they all have their own formula. They stopped creating individual formulas for the shapes once we started to get into shapes that have 5, 6, 7, 8, 9, or more sides. So we're going to talk about how do you find area of these regular polygons. And we can only do this on regular polygons. Remind me from what we talked about yesterday, what makes a shape regular?
If that, like, the sides and the angles are equal.
If all the sides and all the angles are equal. So I can't do this for like an irregular polygon. So if I had a pentagon, something with 5 sides, and all the sides are different lengths, then I can't do what we're going to do today. I can only do it for these kinds of shapes. You can even see on my screen here, there's some examples of what these look like. They look pretty nice, like they're all going to be able to be like inscribed inside of a circle. Remember we talked about inscribing things way back at the beginning of the year when we were doing all those constructions. We were putting these shapes inside of circles like this. So those are the kind of shapes that we're going to be talking about today. Now with this, there's some new vocab that we need to go over so that you know what I'm talking about when I use these words or when we're maybe looking for something to help us find the area. So I'm just going to use this picture of this triangle over here that's put inside of this circle. So that triangle is inscribed in that circle. And there's 3 things that we need to talk about. There's a center, there's a radius, and there's an apothem. Apothem is like a new word that we haven't seen before. Center means the same thing as it did with like a circle. We've talked about the center of a circle before. That's going to be the middle point of your shape. In this case, the center is going to be on your polygon. So it is still in the center of the circle, but it's also going to be the center of that triangle. So I'm going to go ahead and write down over here that the center is going to be the middle part of the polygon. And it's going to be equidistant. Okay, remember equidistant means equal distance. So it's going to be equal distance from the corners of the shape, the triangle or the square or whatever your shape is, and the sides. So I'm going to say it's equidistant from corners and sides. So this center point right here is the same distance to these 3 corners on my triangle. So if I actually drew those lines in, they would all be the same, and it's the same distance from all 3 sides. So again, if I connected the center to all 3 sides, it would be the same distance from that as well, as long as I go to the same point on all 3 of my sides. Most of the time when we do that, we're thinking about drawing like perpendicular lines. So we're going straight to our sides and making a 90-degree angle with that. Okay, then we also have something called a radius. Now again, when we think about a circle, the radius goes from the center to the edge of the circle. When we're talking about a radius on a polygon, we're still going from the center, but you're going to the corner of the polygon. So when it says radius here, we're going to say that this means you're going from center to the corner of the polygon. So there would be 3 ways for me to draw the radius on this specific shape because it's a triangle and the triangle has 3 points to it. So I could go from the center point to any 3 of these vertices of the triangle. It doesn't matter which one I go to, but those would all be my radius. So I'm just going to draw one in. I'm just going to connect it. I'm going to put a little R next to that so you guys can kind of see. That goes from the center to the corner of your polygon. So if you do that for a square or for a hexagon or whatever your shape might be, you have to go from the center to the corner in order to make a radius. Okay, this third word up here, this is this new one. Okay, it sounds kind of funny, apothem. That's going to go from your center to the side of your polygon. And it is going to hit at a right angle. So So I'm going to draw that in too. But when you connect this, you're going from the center to one of these three sides. So again, it doesn't really matter which one you go to. But you're going to just make sure that when you connect it to this side or to this side over here or to this one down here, that it creates a 90-degree angle when you draw that line in. So I'm just going to go off of that same point, and I'm just going to go straight down to this side. And I'm going to put a little A next to it. And then I am going to draw that little right angle box here to just remind myself that it has to be 90 degrees. So before we even get into finding area, we're going to practice just drawing in the radius and the apothem here. So there's 3 polygons that are all inscribed down here. Okay, we've got a square, a pentagon, and a hexagon. I just want you guys to take a minute, and I want you to practice drawing a radius and drawing an apothem. Okay, why don't you guys go ahead and compare with someone sitting next to you and see if you guys agree with how they drew their radius and their apothem. So take 30 seconds to kind of compare with each other. Okay, I have my 3 up here. If yours doesn't look exactly like mine, that's okay. Because remember I said you could go to any corner for the radius. So I did mine just down to like the, I don't know, bottom left corner on my shapes. But you guys could have gone to anywhere else if you wanted to. But make sure for your radius you're going from center to one of these dots on the edges here, one of those corners. And then apothem needs to be going straight down. Now if you notice at mine, what am I essentially creating when I draw on my radius and my apothem there? What kind of triangle? A right triangle, okay? So I usually do that because it helps me when I start getting into finding my area. Because that's what we're going to kind of transition to next, is how do we start finding area using this information? Okay, so I'm going to go over an example with you. We actually have a few different shapes that we're going to do. We're not going to necessarily expect you guys to find the area of any type of regular polygon. Usually we keep it with triangles, squares, and hexagons, but you could do this on any shape. Okay, we could do this on an octagon. We could do this on something that has 20 sides if we really wanted to. We're going to go over the triangle first, okay? But before we even get into finding area, we need to reflect back on what we did yesterday. We talked about how to find angles inside of our regular polygons. We're still going to need some of that information here today, because if I look at just this problem, it says, given this equilateral triangle with a radius of 6 centimeters, determine the area. So what does the word equilateral mean?
All sides are equal.
All sides are equal. They're telling you this is a regular triangle. Okay, equilateral is a fancy way of saying this is a regular triangle. Now they're telling me my radius is 6, so let's draw that in. The center of your triangle, just kind of estimate where you think the middle would be. Just draw a point there in the center. My radius would be going from that point to one of the corners. So like there, they're telling me that this is 6 centimeters. That's all I know about this triangle. I don't know how to find my area yet just by using 6. I can't just take this 6 times a magic number and get my area. There's not a formula for me to plug in that says like base times height divided by 2. Okay, we don't have that for a polygon like this. So even though we're dealing with a triangle right now, I don't have enough information on this triangle to do my base times height divided by 2 formula. I don't know what my base is, and I don't know what the height is of this triangle. All I know is that my radius is 6. So I need to do some more work to figure out what I can do here. Now let's draw in the apothem. So remember, I'm doing that to kind of create this right triangle here. And what I like to do is figure out an angle. Now let's think about what we did yesterday. How could I figure out a corner of the triangle? How many degrees is a corner of this regular triangle?
60.
How'd you get 60? Yeah, this is a triangle, so we know that the angles add up to 180. Okay, if it's all equal, 180 divided by 3 would be 60 degrees. So each corner is 60 here. So like this whole corner over here would be 60 degrees. When I drew in this triangle though, it's going to, when you draw in that radius, it's actually going to split that angle in half. It's going to bisect it. So I'm not actually using the 60 degrees, I'm using half of it. Half of 60 is 30. So I'm going to draw this triangle down below, like this right triangle that I'm focusing on here. Okay, we know that this is my apothem side. We know that this is 6, and we just found this angle to be 30. I should be able to figure out what this is, the apothem, or I could figure out how long this bottom half is as well, if I wanted to figure out maybe the area of this little triangle. If we look at this shape, if I drew in all of my other radii, so if I went from my center to all my other corners here, and I drew in all of those other apothems that would be in there, I'm just going to show you what that would look like. There's all my radii, and there would be all my other apothems. How many right triangles am I creating in here? 6, and they would all be the same triangle. So if I found the area of one little triangle, I could take that times 6 to find the area of my whole shape. Now we're back to this triangle. This is a special right triangle because it's our 30, 60, 90 triangle. Okay, I drew the triangles over there on my whiteboard. Let's review the pattern really quick for these two triangles because we're going to need to use these today. So we're on this one right now. Does anyone remember how we would label our sides for a 30, 60, 90 triangle? Colby?
The shortest side is 6, and then 12, and then the hypotenuse is 13.
Say that again.
The shortest side is 6, the hypotenuse is 13, and the other leg is 12.
Are you using those numbers up there?
No.
We use letters to represent the sides. Do you remember what the letters were?
No.
Does anyone remember what the letters were on the 30, 60, 90 triangle? You use like S's in that to represent sides. Do you remember what went where? This was S.
Side 1, side 2.
No. Okay, this was S radical 3, and this was 2S. Is that ringing a bell for anybody? Mr. Akers would have taught you guys that. Okay, let's talk about 45, 45, 90. What's the pattern for this one? There was an S radical 2 here.
The other ones are just S.
The other ones are just S. All right, I'm going to keep those up there. So if you guys look at this special right triangle we have up here now, how would we label this? Where does my S go? Where does my 2S go? My S radical 3.
S radical 3 would be the S2 would be the hypotenuse.
Okay, so this side is 2S. What would the apothem side be? It's across from the 30.
S radical
Careful. Across from 30.
F.
S. So this side would be S radical 3. All right, if your 2S side is 6, how much is just S then?
12. What?
You would set these equal.
Oh, you don't like time them?
No, we're saying 2S is equal to 6.
And 3.
Then 3. So S is 3. So that means that your apothem would be 3. And down here would be 3 radical 3. Okay, so here's my triangle that we pulled out from my polygon here. I grabbed this triangle and I dropped it down here. I'm using my 30, 60, 90 triangle properties to help me get these sides. Now I can find the area of this triangle because we have a formula for that. It's base times height divided by 2. So I'm going to bring that over here to the left. For my little triangle, I'm just going to write that out. Little triangle, we have base times height divided by 2. Okay? Your base is this 3 square root of 3. Your height is this 3 here. And then we're going to cut that in half. Now, I can't really do anything with this radical 3, but I can work with my numbers here. So what's 3 times 3? 9. And then if you divide that by 2. Okay, so I'm going to write 4.5. Radical 3 is just going to sit next to it. Because if they want me to do this, they probably want me to have exact answers. They don't really want me to multiply by that square root of 3. Okay, but how many triangles did we say made up this entire shape? 6 of them. So this is just the area of one of these little guys. So I need to take that times what? 6 to get all of them. So just take 4.5 times 6. 27? So it'd be 27 radical 3. And then I would label this centimeters square. Okay, there is another way we could have solved this. I'm just going to show you guys how this works. There is a formula-ish that we can use for regular polygons. It looks like this. When you're working with a polygon, you can take the apothem, if you know it, times the perimeter of your big shape, again, if you know how long a side is, divided by 2. Now, we could still do that for this problem. It does not negate the fact that you're going to have to still do this. Okay, so I'm not saying that this is necessarily easier or that it gets you out of having to work with special right triangles. You're still going to have to do a little bit of that today. But if we look at this triangle here, if I wanted to use this formula instead, we said our apothem was 3, right? So I could still plug that into my formula over here. So a 3 would go in for that little a, but I need to figure out what I would put in for my perimeter. This side that we found using our special right triangle was 3 square root of 3, but that's only half of this side. So how long would this full side actually be? 6 square root of 3. So like from here to here would be 6 square root of 3. How would you find the perimeter if you know that each side is 6 square root of 3? Take this times 3. What is 6 times 3? 18. So you could put 18 square root of 3 in for your perimeter because you're just using, again, the special right triangle to get to your side. Let's just do this math here. What's 3 times 18? And then divide by 2. 27. We get the same answer. But if you want to go this route and use the apothem and use the perimeter of the shape, you can. I think sometimes students like that a little bit better because they're not having to think about all the tiny triangles that make up their shape. But if you like to divide it into the triangles, you can continue to do that. You're going to get the same answer whether you use the formula or if you use the little triangle and use that formula from the past and just multiply it. Okay, so going forward, I'm probably going to lean more towards using this method here. But you can still use this one if you guys would like to. I just wanted to show you both. But I want you guys to flip your page over because we're going to do another one. All right, so this time we have a hexagon, and we have our side of 8 centimeters. So where should I put the 8 at? One of the sides on the outside of the shape. It doesn't really matter which one, so I could put it here. Now, if I'm thinking about my formula that I just gave you guys, area equals apothem times perimeter divided by 2. Could you find the perimeter? Yeah, you would do 8 times what? How many sides does the shape have? 6. So you would take 8 times 6, so your perimeter would be 48. Okay, that's not so bad. But I'm missing my apothem this time. I still need to find that. So let's think about what we would do as far as our little triangle goes. So I'm going to draw my center in. Again, just kind of eyeball where you think the middle of that shape is. And let's draw in our right triangle. So I'm going to connect for my radius, the center to the corner. And then my apothem goes straight up and down. From the center to that side that I labeled 8 centimeters. Make sure it's nice and 90-degree angle there when you hit it. When I look at this little triangle here, I'm going to pull this out. I need the apothem side. This whole side was 8, but when you drew this in, guys, what does it do to that side?
4.
Cuts it in half. So the bottom of this triangle is only 4 centimeters. It's not 8 anymore. All right, let's figure out what this angle would be. So what's the degree of one angle on a hexagon when it's regular? 120. So this whole corner here is 120. If you don't remember that, we did all of that yesterday. You have charts in your notes that have all those angles in it. So if the whole angle is 120, how much is this angle? 60. Which means that up here would have to be 30. Okay, we're still using a 30, 60, 90 triangle like we talked about over there on the board. What side is your 4? Is it your S, 2S, S radical 3? It's across from the 30. This is your S side. What side is the A? It's across from the 60. S squared of 3. So how much is the apothem? 4 squared of 3. If S is on the 4 side, you just put 4 in here. So the apothem would be 4 square root of 3. I now have my perimeter. I have my apothem. I should be able to go to my formula now. So back up here, we're going to take 4 square root of 3 times the perimeter, which we said was 48, and we're going to divide by 2. Again, just work with your whole numbers. The square root of 3 is going to attach to your answer here. So you're going to take 4 times 48 and divide by 2. What do we get? 96. And then we have to attach square root of 3. And what's my label? Centimeters squared. Does that make sense how I got there, guys? We're going to do one more. All right, this last one we have here is our square. I'm going to just start out by drawing in my center, and then I'm going to draw my radius and my apothem. What can we label? What information are they giving me? The radius is how much? 8. So where does that go on my picture? On the hypotenuse of the right triangle. Okay, so I don't know apothem, and I don't know my side, so I can't find perimeter right away, but we can work towards it again. We're going to pull this triangle out, and we're going to see what happens here. This is a square, guys, so how much is this corner? 90, so half of it would be 45. Okay, so I'm going to pull this triangle out. This is a 45, 45, 90 triangle, which means whatever the apothem is going to be the same as down here. And this is 8. How do we label this triangle? What side is the 8 reflecting on my 45, 45? S squared of 2, which means these are both S's. So when I get my apothem, that's good for my formula. What will I have to do to this side to help me get to perimeter? When we find this, you'll have to double it, remember, because that's going to be your full side. And then we'll have to then multiply it by 4 because there's 4 of those to find perimeter. All right, so let's work through this. We got to solve for S here. This is going to be not as cut and dry as those other ones. We've got S squared of 2 is equal to 8. We've done this though before in the past. How do we get that S by itself? We divide by the square root of 2, right? And then can we leave it there? What do we need to do? Times the square root of 2 on the top and on the bottom. Okay, so this over here, this is gone. So we've got 8 square root of 2. What happens on the bottom there when you take a square root of 2 times the square root of 2? It's just 2. Can I divide 8 and 2 there? So my S is going to be 4 square root of 2. So that's going to be 2 sides for me on this triangle because I have a 45, 45, 90. So the apothem is going to be 4 radical 2. So I'm going to write that over here. My little a is going to be 4 square root of 2. That also means that half of the bottom side is also 4 square root of 2. So how much would be a full side? 8 square root of 2. So if from here to here is 4 square root of 2, you just have to double the 4. So a full side is going to be 8. I'm going to write that on the top. What do you do with this to find perimeter? Times by 4. What's 8 times 4? So my perimeter would be 32 square root of 2. Now we can find our area. We've got our apothem. We've got our perimeter. So to find area, we're going to take 4 square root of 2 times my perimeter, which is 32 square root of 2, and then we're going to divide it all by 2. Your final answer should not have a square root in it anymore. Do you guys know why? These are going to cancel each other out. Like these square roots are going to cancel each other out. So you're going to have 4 times 32, then it's going to be times 2, because that's what this is going to become, and you're going to divide by 2. Or, since there's a 2 on the top, that cancels with the 2 on the bottom, you can just take 4 times 32. What do you get? 128, and what's my label? Centimeters squared. So again, the area of a regular polygon formula is apothem times perimeter divided by 2. Okay, or what we started out with at the very beginning of class today is you find area of your little triangle and you take that times the number of little triangles that you have in your picture, and then you divide by 2. If you liked the little triangle method from before when we did it on the first one, you could have still applied that to all of these other ones. I just didn't go that route. All right, I'm going to give you guys your worksheet over regular